So last time we stopped here. We started discussing pointers, one of the most confusing topics in C. I hope last lecture at least introduced you to pointers and how to deal with them. Today we are going to continue the same topic. Again, if you have any question, please let me know, because this topic is important. It's actually very important even in general programming. It's important for whatever coming course. And the pointers concept is the same no matter what is the programming language you are using. For example, if you're going to program in the future using Java or something else, pointers are pointers. So the concepts are exactly the same. This is why it's very important. This is why I'm paying attention to what is happening behind the scene, what are the concepts behind what's going on, how the memory is structured, and why we need pointers, how they are used. And then the syntax is what is limited to C, but then it's very similar to other languages as well. Right? If you have any question, let me know. So today, we didn't discuss this last time, right? Or you don't remember? Did we discuss this? Swapping two variables, a function? Okay. So by the way, all the lectures are on Avenue. Since I guess the second week of the course, you guys requested that I put the lectures before. So since then, I have been doing this, if you don't know. So you already have these lectures so that you can take notes during the lecture. Okay, so what we want to do here. It's a very simple function, similar to what we were doing before. You want to swap two variables. The different thing here is because you want to swap two input parameters, then the result is not just one output, right? So if I asked you to write a function that returns the like the maximum of two numbers or three numbers or n numbers, then the output is just one variable, right? If I asked you to sum two numbers or subtract two numbers or divide two numbers, the output is just one variable. Functions in C and in most programming languages have this limitation. You can return only one variable, right? In basic ways. Then here we want to swap two variables. That means my output should be two things, right? Because this is the result. How I do this? We discussed before the concept of passing something by reference, which means you don't pass the value of the variable itself, you pass the memory location of that variable, right? We already discussed this before. Today we are going to put everything together. Some things we covered in variables, some things we covered in functions, something we covered in arrays and pointers. So today's lecture is actually dependent on all the lectures we discussed so far. So if you missed one concept before, then it's the time to get it. And if you didn't imagine how things happen together, today we are integrating this together. So today is a very important lecture actually. Right? So we want to swap these two. That means we have to pass them by reference because you want to change both. Good? There is no other way to do this. Good. So, and this is the AND thing. You remember from last lecture we said AND is the address, right? So you are not passing A, you are passing the address of A to the swap. Or in other words, because we already started pointers last lecture, in other words, you are passing a pointer to this variable, not the variable itself. Right? And this is why swap doesn't return anything, because the result of swap will be reflected in the two input parameters. Right? What we do here is because you pass an address, you read this in a pointer. And this is the first time we see these two things. How to input a parameter to a function as a pointer. It's the first time we see it as this syntax, but we have seen passing an effective pointer to a function before. Does anyone know what is that for a bonus mark? So what I'm saying is, this is the first time we see something like this syntax. You are passing a pointer to a function. But before, we had a very similar, not very similar, it's the exact effect, but in a different syntax. Yeah? When you were passing arrays, because we said array, name is the pointer to the first element in that array, right? Effectively, it's a pointer, it's a memory address. And this is why, again, passing array to a function is going to change it, so it's by default a passing by reference. why you can, the function when it reads an array as an input, it has the ability to change it. Why? Because array is a pointer, effectively the name of the array is a pointer to the first element, and you are passing a pointer to a memory location. That means if you make any change in this memory location, it will reflect. It's not like passing a variable. Right? And this is the basic concept in pointers. You have to differentiate between the value of a variable and the memory address or the memory location of that variable. Right? Okay. So we define two pointers. The read addresses, so they have to take this. Why these are int pointers? Because the variables themselves are integers. So why the pointer has to be a type of int, right? And then what you will do here is I define my temporary memory location, because you have to define a temp thing if you want to swap. You assign, what does this line do from last lecture? Yeah? Yeah, you assign the value that y pointer is pointing to the temp. What is this value? This is y pointer. It takes the address of P. That means this is effectively P. Right? Is that clear? So what I'm doing here is, this is dereferencing, pointer dereferencing. This is the term that is used in programming, but aside from the term, we said this and is an address, this asterisk is a value. If you see the asterisk in front of a pointer, not in the definition, but using it in the assignment, that means you are using the value that the pointer is pointing to. Good. So this is B, you put it in temp, and then you switch Y and X, or effectively A and B, and then you assign them. Basically, this is the basic swap, 3 lines that you have seen multiple times before. Is there any question here? No? So if you want to see what's going on, assume A and B are 100 and 200. You define these two pointers. Right now they are not pointing to anything. But once you call the function that goes to swap, this X pointer will take the address of A, this Y pointer will take the address of B. And then inside the swap function itself, you define the third memory location, which is N, 4 bytes. By doing this, temp is equal Y pointer. You go here, take the value that Y pointer is pointing to, 200. It goes to temp. And then third line, what you do is you take X pointer, which is A, go to B, and then you put A in your, you put temp in your A. Right? This is a kind of tracing or simulation to what's going on. Good? Any question? Okay. So the thing that we want to do here is, I want to write a function taking the same concept even further. I want to write a function that takes two input parameters and returns to me the sum and the difference between these two variables. Now I want to return two things, which means what? I cannot use this. I cannot use the normal return process of a function to return both. You can only return one of them, right? But given now we know pointers, you don't even need the return, because what should I do here? Can someone imagine or say what would be the prototype of the function? It takes two input parameters and you want to return, or you want to find the sum and the diff. Yeah. But I don't want to change X and Y. What I want to do is read X and Y and calculate their sum and difference. So if I only read X and Y, how would I reflect back? Think always in a function, think of what are your inputs, what are your outputs. It's like a black box, right? You read two things, which is X and Y, that's true. But you want to return completely two different things, which is the sum and the difference. What you're saying is, I can return the sum and the difference each in X and Y as well, right? This is what you're saying? Let's say I don't want to do this. Let's say I don't want to change the two input parameters. Yeah? Yeah, so pass to the function as well another two inputs. You call it sum and difference, and then use this to calculate whatever you want to calculate and keep X and Y the same, right? So the prototype would be just explanation of what we have just said. And then the prototype, this is calling the function, so you have x and y, and then these are the two variables that you want to change. Here, I'm passing x and y by value. Why? Because I don't want to change x and y. I'm just reading them. But I'm passing sum and def by reference, because these are my results, right? And then, let's just go here. So, the prototype of the function itself would be a and b, normal variables, and then here, 2 pointers to read the sum and def. These are effectively not inputs to the function. These are outputs, right? So maybe initially they don't even have a value in the main function or the caller. They will get their value after calling the function itself. Good? What I would do inside the function is I'm just going to assign the value of a plus b to the sum pointer dereferencing thing, which means the memory location that the sum pointer is pointing to is going to hold the sum of a and b. Similarly, the memory location of like the def pointer is pointing to is going to hold the difference, and then I'm done. Right? Just 2 lines. Good? And because these are pointers, they are going to change, or the change will reflect on the main function as well. So when calling this, sum and def will actually have the sum and difference of these 2 numbers, right? So sum def in the main are variables. Some pointer def pointers are pointers pointing to these variables. So if here you are not actually changing the pointer itself, this is dereferencing again, so you are changing the variable that the pointer is pointing to. I feel like I'm repeating myself 1,000 times, but that's okay. If you get it, this is the important thing. So if you have any question, let me know. Yeah. Storing it as a pointer. Which ones you are referring to? These 2? Yeah. So these are pointers, right? Pointers, we use them as addresses to a memory location. But at the end, you want the result of this sum, and this is what is important to you, right? This is the logic that you want to implement. But you are not going to store the sum into the pointer, because the pointer is a memory location. You want to store the sum in a specific memory location, not a memory address, right? You get that? So without this dereferencing thing, without this asterisk, this is not going to work, right? So the trick of a pointer is you use the address to change the memory location, not change the address itself. Because if you do this, then what is the difference between a pointer and a normal variable? It's nothing. Yeah. Good? Okay. So again, a simulation to what's going on. Some pointer, def pointer are pointing to 2 memory locations, and then a and b has certain values. You do the sum, and by doing this, you take the sum, put it in the sum, and then, so let me say step by step what happens behind the scene, at least for one time, for the sum, for example, right? So this line, what the compiler will do is, this is a pointer dereferencing. That means I should go to the sum pointer value, read the address, go to the memory location that the address is pointing to, and use this variable. What I'm going to use this variable in, assign the sum into the variable. So add these 2, 300, take the address, go to the memory location, put the 300 here. This is what compiler or the hardware at the end is going to do when you execute such a program. Good? Okay, the same thing for def pointer. Any question? Okay. So we continue discussing pointers, but by adding things together, pointers and arrays and dealing with functions. And at the end, if we have time, we'll discuss dynamic memory allocation in C. Let's see. Okay. So one thing we have been doing so far is using the pointer as an address to change a memory location. But we didn't do any math operations on the pointer itself, except for the array, because I explained to you, and this is one thing that we will revisit today, that array name is a pointer to the first element, and when you access an index or one entry in the array like A5, for example, what the compiler is doing some math operation in the A. So it reads the address of the first entry, assume this is an integer array, each entry is 4 bytes, and you want to access A5, so the entry number 5. Then what the hardware is doing is take 5, multiply it by 4, because each entry is 4 bytes. This is 20. You add 20 to the actual start address, and this is going to be your location to the entry number 5 in the array, right? So this is somehow a math operation on the A, which is the pointer to the first element. So today we are generalizing this, not just for arrays, for pointers. If you want to do some math operations on the pointer itself. Why I would like to do this? I already give you one example. Like, you know that array is contiguous in memory. If you have the pointer that is pointing to one element, you should do some math operation, addition or subtraction, to move throughout your array, right? So this is one example to do this. If you add something here, like b plus I, this is advancing the pointer by I entries. And one very important thing, this is basically the main difference between doing math operation on a pointer and in a normal variable. If b is a normal variable and I want to add I, and I assume I is an integer value of 5, what will happen? You take the value of b, you add 5 to it, and that's it. Right? Very basic. We have covered this in the first lecture. But if p is a pointer, it's completely different. Because if you read the address of p, you are not going to add 5 to this address. It means nothing. b is a pointer to a certain data type. Assume b is of integer type, right? That means each element that b is pointing to is 4 bytes. So if you say, I want to do b plus I, and the I is 5, logically, you don't want to add absolute 5 value to the pointer itself. You want to read the variable that is pointed to by like a part of 5 memory locations from the certain variable. What does that mean? Again, let's go to the array example. You want to visit A5, but A, the pointer that is pointing to the first address is at A0 by default, right? If you say A plus 5, this should take you to the A5, not to the 5th byte after A, because the 5th byte after A is, can someone imagine where is the 5th byte after A? So let's say I have this array. So let's say I have this array, and this is 0, 1, 2, 3, 4, 5. I want to access this one. And I know that if this is array A holds the address of the first element, right? If I do A plus 5, what you expect logically is this should point to this entry, right? But if you add the absolute value of 5 to assume this A is just 0x0, is like first element is at address 0. If you take 0 and add absolute 5 to it, that means this is address 5, right? And this is int. Can someone tell me address 5, where exactly it points? Yeah? Yeah, it's actually not the beginning of the number 1. It's the second byte of the first of entry 1, right? Because entry 0 is from 0 to 3, because it's 4 bytes, 0, 1, 2, 3. Right? And then entry 1 is starting from byte 4, 5. So I'm going to point to the second byte of entry 1. This makes no sense. Right? So effectively what you want to do here is add 5 to not the pointer value itself, but to the segment that the pointer is pointing to. So if A is an array of integers or pointer of integer type, you want to increase the memory not by 5, by how much? 5 multiplied by 4, the size of the integer. Right? Makes sense? Because effectively this one is at address 20. Come on. Sometimes you shouldn't trust technology. Okay, this one is at address 20 because this is at 0, this starts at 4, 8, 12, 16, 20 because it's integers. What if array A is of type character? It's different because integers are 4 bytes but characters are just 1 byte, right? So if A is array of characters, this is going to be address 0, 1, 2, 3, 4, 5. In this case, you don't multiply 5 by something. So to generalize this, what I should do is not use the absolute value that you want to add, but multiply it by the size of the type the pointer is pointing to. Make sense? We'll see some examples now. So this is a double array. I define a double pointer. To assign some value to the pointer, I can do this, right? What a pointer would be doing, it's going to point to A4, right? Because I take the address here. You can say a pointer plus 3. Which element this is going to point to? Can you see? A7, right? Right? Did you get that? So, what is going on here? This is dereferencing, but before you do the dereferencing, you do a math operation on the pointer, right? So we calculate it one by one. A pointer holds the address of A4. You add 3 to this. We said this calculates to A7 address, and then you do dereferencing. That means this is equivalent to say A7 equal 10, right? So here we combine math operations on pointers with dereferencing. So you can also subtract if you would like. This is going to point to element number 2, because originally we were at A4, this is going to be A2. And what you're doing here is assigning A2 equal 10. There is one risk or one dangerous thing about using pointers to do assignment to array elements. What is this one? What is the risk? Yeah? Can someone, yeah? Yeah, because again, C has no boundary checking. If you do this math operation, and here it seems very simple because you have a static value, 2. It's just an immediate value. But generally, 2 can be anything, can be another variable that you calculate from other things. This is a normal C expression. So this subtraction, you can subtract anything. And this variable can be calculated from another thing, so the program can be complex enough. You want to check that you are not indexing an element in the memory that you don't know what is it. So you have to stay within your array boundaries if we are discussing arrays. Okay? So one possible math operation is the pre-increment, right? So you pre-increment your pointer and then you assign it a value. So if a pointer here is pointing to 4, you pre-increment it to 5, then you go to element 5 and then assign 10, right? So far, these examples, we're doing math operations in pointers, but using immediate values. I said also this can be any other variable, but a pointer in C is nothing other than a variable. So can we do math operations using 2 different pointers? Can we subtract 2 pointers, add 2 pointers together, right? Then yes, we can do this. So let's say I define 2 pointers, A and B. This is again an array. And then A pointer is pointing to element 8, which is this one, 18. B pointer is pointing to 3, which is 0, 1, 2, 3, 13. And then I do subtract both. But here what I'm subtracting is not the value. Can someone say what is the value of I? And this is for a bonus mark. Yeah. 5. The reason is 18 minus 13, right? Not true. This has no dereferencing. It doesn't have the asterisk thing. So you are using a pointer as the address, right? Then, yeah, which is it? Oh, okay. That's right. That's true. Well, I should have different numbers here, because in both cases it will be 5, but that's bad. Yeah, thank you. Yeah, that's true. So basically, a pointer minus b pointer will take the difference between the indices, the entries, right? Not the values in the entries, but here it happens to be the same, right? Good. So it's 8 minus 3, not 18 minus 13. This is a bad example. Okay. Okay. So one thing to learn is the difference or the addition would be an integer value. Again, I told you pointers are memory addresses at the end. Memory addresses are positive integer values because you don't have a negative address and you don't have a floating point address, right? It's an integer, like this makes sense. Memory is a physical thing, so you don't have a negative memory location, right? So the difference between them is an integer value. But this may confuse you that a pointer is also of an integer value, but that's not true. A pointer is a type of its own in C. It holds integer values, right? Because it doesn't take negative values or floating point values, but it has its own type, yeah.
Will the compiler throw an error, or like will it throw an error at runtime if it finds a negative pointer?
Yes, but it will do this, but if the expression, so if it's very clear, like you're saying, you're defining a pointer like this one and saying -2, it will complain, right? But if you are doing complex math operations, the compiler may not be able to detect this because the compiler has different levels, right? So first it does a syntax check, but it doesn't calculate so you need to know what are the values to know whether the result is a negative value or not. And you will not know the values until you execute it. So in some cases you will get an error if it's an immediate value that is clear to the compiler checker, or in some other cases you may need to execute and then it will give you a segmentation fault when executing because the expression wasn't clear at the beginning, and then when you executed, the hardware found itself that it has to go to a memory location that does not exist, and this is segmentation fault. Right? So it depends on the case. Right. Okay. So this is explaining what happens behind the scene to get the difference of 5, right? We calculated this 5 ourselves by saying, okay, this is at location 8, this is at location 3, I calculate the difference, right? But this is an integer array. Another thing would be like a double array or a character array, right? So difference is in number of entries will be the same, but the actual number of bytes, the address itself will be different. What I mean by that? 5 entries in an integer, they will have a memory size of 5 multiplied by 4, 20 memory locations, right? But 5 entries in character have 5 memory locations because each one takes only 1 byte. It's 5 bytes, right? For double, if it's 32-bit, then the same as the integer. If it's 64-bit, then it actually holds 8 bytes. So you multiply 5 by 8, so it's 40 bytes, right? So size of is a function. We will see this function later, but what you need to know now is size of gives you the actual size of the type. So size of int gives you 4 bytes. Size of, we tried this when I asked you to try in your machines what is the size of an integer, what is the size of a floating point number. We tried this before, right? Okay. Here we have another example, and this is, assume this is my memory. So what I'm doing here is I'm defining an array of 5 elements, A, and then assigning a pointer B to the first element of that array, A. So now B is pointing to 10, right? The first element. And then in the line here, I'm printing the value of B. Can you imagine what is the result of this print? By now we should know this as our names, right? So we had so many examples. So what would be the result of this printing? Yeah, 10, right? So here I'm doing dereferencing. B is pointing to A. A is an array, which means the name holds the address of the first element. This should be 10. And then I'm increasing my pointer, B++. Now by doing this, B is going to point to 20. So if you print it, what you would expect from this line? Someone from the back? Yeah? The memory location or the address of 20, not 20 itself. The reason is I had the specifier as B and I'm not doing dereferencing. So I'm printing the address itself. And this is the trick here. Here we printed the value that B is pointing to, but here we are printing B itself, which should be the address of 20. And then I'm increasing by 2, going to 40, doing the same thing. So originally B is pointing here. B++ is going to point to A1, and when I print this one, it should give me this address, right? And then B+2 is here, which is 2 memory locations after the A1, which should be A3. So something you see from this memory here is each element has 4 bytes, right? Because these are integers. So you print the first line gives you 10, the second line gives you B after you increment it by 1, which is 0x22AA04. And then you increase B+2. This is jumping here to A3, which is 0C. Any question? No? Okay. So we already started by discussing this. This is just for your reference because I discovered that I didn't have this written in the slides. Yeah. Yeah, go ahead. Will you say this again? After 0405. Oh, here, you want to access this one, right? Yeah, that's a good question. So how would I access this one? If you want, right? So, first of all, do you find a use case that you need this one under the following example we have? This one doesn't have a readable value. So assume I want to get this, right? And this is something that is very important to know. When you define, and forget about pointers, and this is a very important question. So, but I'll start earlier with that. So I actually thank you for the question. Please give me your name after the lecture. So your friend here is asking, you keep telling us that assume basically this is an integer of arrays, I access this one, if I add 1, I go to A1. But what if I want to access something in between? How would I do this, right? This has so many aspects. One of them is called memory alignment issues. Assume you forget about pointers completely. You just define an integer variable called x. Once you do this, it blocks 4 bytes to you in the memory. To make it easy to the software, the hardware abstracts the 4 bytes as one entity to you. We see here in hardware, these are actually 4 different bytes. But the software sees them as completely one entity, which we call x in our variable, right? This has the advantage of making it very easy that you read the 4 bytes at once together. But it has the disadvantage of you don't have the fine-grained control of taking 1 byte out of this. But what if I want to do so? You need to do an extra step. Read the 4 bytes, and then, for example, you guys know AND OR operations, so you can mask some of the bytes, and we will see some of these things later. Assume A1, you said I want to access 05, which is the second byte of A1. Assume A1 holds this value. These are 4 bytes, so this is 1 byte, another byte, and then let's say this, and then this. I'm writing this in hexadecimal, right? This is 1 byte, 1 byte, 1 byte, right? Assume these are the values, but it doesn't matter. This is another example, good? So this is the value that you want to read, which is the first byte, right, of A1. How would I do this? Read A1 as a whole, do AND with all zeros except this one, right? And this will extract this byte for you. Because if you AND something with zeros, it gives 0. If you AND something with 1, it gives you the same value. This is called masking, right? So it's an extra step if you want to extract a certain byte out of a variable. Okay? Why? Because the normal use case is you don't do this. So usually everything in computer engineering is done to accelerate or to increase the performance of the usual use case, right? So the usual use case is if you have an integer variable, you read it at once. To make it fast, the hardware gives the software the access to the complete 4 bytes, not just byte by byte, because it will be slower if you do it byte by byte, right? I hope this answered your question. Okay, yeah, but I like this kind of question. So I said we already discussed this before. The name of the array is actually a pointer to the first element of the array, and you can use it as a pointer. But the thing that we are going to add now is we all had actually these things before, so it doesn't make sense. The only difference that you need to know is, yes, the name of the array is a pointer, but it's not a variable pointer. You cannot change it. If you define an array called int a5, a itself is a pointer to the first element, but you cannot do math operations on that. And this is intuitive, because if you change a value, now you lose the access to this array, right? A has to keep pointing to the first element. So it's a static pointer, or a constant pointer, not a variable pointer. And this gives us some differences in practice. It's not just like an abstract difference. So AA is a pointer to AA0, AI plus I is pointer to AI. We already know this, but I'll come into this later, but this is not what I want to do now. What is that? Okay, so this is the thing that I want to say. Is because assume, I guess I have a slide about this later. Okay, this one. So, I kept telling you that array name is a pointer, right? And you can use it as a pointer. But the thing is, it's a constant pointer, so you cannot change. And this makes a slight difference between normal pointers and the name of the array. Inside a function parameter, like if you pass an array to a function parameter, they are completely equivalent. And the reason is, arrays are passed by default by reference, because it takes the address of the first element, and you can operate on that, right? But outside input parameters to a function, you cannot do math operations on the array pointer. Why? Because it's a constant array. So here, something like int a3, and you do this, we know you can initialize your array by the 3 values, right? But if you define a pointer, if these two are completely equivalent, then this should be accepted, right? But can we do this? We cannot, because Q is of type pointer, not an array. So the syntax is different, right? So you cannot say, I want to initialize an array by value 135. But this means nothing, right? Q is going to point only to one element, but the array by default holds multiple elements. In fact, the number of elements that you initialize it with. So it can say 135. So the compiler understands this, as we explained before, by saying book or reserve to me 3 entries in the memory, point out to this by A, and the value should be 135. But for this line, the compiler will understand this as declare a pointer to me called Q. This should point to an integer. What is this? Right? I don't know. Like, is this the integer value of the Q? But Q should hold an address, not 3 different values. Is this the value of the location that the pointer should point to? But it should point to a single memory location, not multiple, right? You see the difference? So, and this is a trick that is always played in coding interviews. To see if you understand what are the differences. Okay, people all know that array name is a pointer to the first element, but are there any differences between them? The first difference is the array name is a pointer, but it's a constant pointer, so you cannot do math operations on that. The second thing is a pointer itself cannot hold multiple elements like an array. You cannot initialize it like this, right? Any question? Okay, let's go back. All of this we covered, but these are more examples. Here it says, so far we have been using arrays and pointers to point to array elements, so we have 4 different combinations to do this. Assume I define an array of 10 elements. I define a pointer and I say b equal a, which means b should point to a0, right? For the 4th time today. And then if I want to access ai in the array, now I have 4 different values or different ways of doing this. The normal one, which is the first one we covered, which is saying ai, right? ai is element number I in the array named a. But I can also say this, bi, and this is a very neat thing in C. Once you point an array to the first, once you point a pointer to the first element of array, you can use the syntax of the array to the pointers. You can say bi as if b is actually an array, but it's a pointer, right? What the compiler will do when it sees this thing, it will say, yeah, what you mean is add b plus I. Because effectively, these two are the same thing. You add I to b, right? You want to access entry number I that is far from the current entry that b is pointing to. But also, I can use dereferencing, right? I can say b plus I, this is an address, take its value, which is completely equivalent to this one. Or also I can say a plus I, take this value and then point to this one. One thing I said is you cannot do math operations on a, like the array name. But how would I do a math operation here? It seems like a conflict of what I have said before, right? I told you that a is a pointer, yes, to the first element, but it's a constant pointer that you cannot do math operations on. But now a plus I is a math expression. Can someone try to resolve this thing? Yeah?
You're not changing the value.
I'm not changing a. What I meant by not doing math operations on a cannot be in the left side of an assignment, right? Here, b and a are not changing. You are just calculating another value that is b plus I, but if you bring b after this, it will remain the same thing. You didn't increase b with I, right? You just calculated an expression that is b plus I. If you say x plus y equals z, z equal x plus y, x doesn't change, y doesn't change, z changes, right? The same thing here, b plus I doesn't change, b doesn't change, a doesn't change, I doesn't change. But you just calculate a summation of both. Good? Any question? You will explore these 4 different things in lab, so if you have any question, let me know. Good. So these are examples, we already covered these. Here, the first one is the one that we had in quiz 2, reading 20 elements, and then assign these elements to an array, right? This is the normal thing. But I can do this using pointers, right? And I can use the same math logic to pointers. So I say b equal a, the first element, keep increasing b until you reach the 20 elements, and then now you're going to print the value of b. If you do scanf, you can read from the user and put it into the memory location that b is pointing to. So these two loops are exactly the same thing. One is using pointers, the other one is just using the array syntax. Does this make sense? Okay. It's already discussed. This is also already discussed. Yeah, so another topic is arrays. So if you think of how is the flows going in, we started with very basic things, types, loops, if conditions, the very basic thing of any programming language. We then went into arrays and functions, right? Both work together, and then we jumped into arrays of characters, which are strings, which still arrays, but have a specific feature in C, which you can deal with them as one entity, as a string, right? And then we covered pointers. We have seen how pointers interact with arrays, with functions. Now it's the logical thing to cover how pointers interact with strings, which are arrays of characters, right? So the basic rule is they are exactly the same thing as normal array. Like strings are arrays of characters, so they are still arrays at the end, and then you can operate on them. But there are some slight differences because of the nature of the array of character, which is just one entity, right? So the examples here are like you're defining a normal array of characters. You do a scanf. This is one of the differences between a normal array and the string array or array of characters, is you can read the whole entity as once. Why? Because I'm using here the string specifier. So what is going to happen in this line is read 20 characters from the screen, input it into the array, right? And then finish this by the null character. Oh, by the way, this cannot be 20 elements. They have to be 19, right? Because you have to reserve one memory location to the null character. Right? So if I assign this string hello world, and then I define another pointer of type character, and then if I do the same thing as I do here, I would have a big problem. Why? Because pointer of a type character is going to point to a single variable of type character, but it cannot point to multiple memory locations. This is exactly the same thing as we have seen in normal arrays by saying you cannot say int pointer b equal 1 to 3. You cannot initialize a pointer as if it's an array. Why? Because it points to a single memory location, not multiples, not like the array. And because string is nothing other than a normal array, so again you cannot do the same thing. The main reason is by defining a pointer, it should point to a single memory location, not multiples, not like an array, right? Good. So here, what you would do is, okay, this is character pointer called s, and then you initialize s as John. What happens here is, because arrays of characters can be defined on the fly, you can say this, but the problem is you cannot change it. It's not, this is going to be in the read-only memory. These two things are not completely equivalent. So the correct thing to do is, if you want to define a string, first of all, define it as a normal array of characters, and then use pointers to point to it, right? So we started 2 minutes late, so I have to. Right. So let's take one example to see what's going on. So character is John. This is the example we had from previous slide, and then you cannot say now dereference is and change j to b.